All right, learning target 2 for unit 5. Find the solution to a system of linear equations approximately by graphing. So you're going to have 2 or more lines, most likely 2. You're going to graph them. So if this was like a graph right here, and here's your 2 lines, blue one and the red one's a line, your solution is going to be right where they intersect. Like that would be your answer, that coordinate point, whatever that is, x comma y. So the solution to a system of equations graphically. So you manipulate the equations so that both equations are in the form of y equals mx plus b. Or you find the x and y intercepts by plugging in zeros. So remember, we did this in previous units. We graph both the lines, and then you find their point of intersection, so whatever that point is. So I like to put everything in this form. That's what I'm going to do. If you want to, you can just graph by finding their intercepts, like by plugging x in for 0 and then y in for 0, whatever you want to do. So let's do a couple examples. So this is already in the form of y equals mx plus b, so I'm going to do this one in red. So y equals negative 3x plus 4. The first thing I do is I do that plus 4. 1, 2, 3, 4. There's my first point. And then it's a negative, so it's 3 over 1. So I'm going down 1, 2, 3, and then I'm going backwards 1. Or I'm going up 1, 2, 3, and over 1. So something like this. 1, 2, 3, 1. And it's negative, so it should be pointing down. So then I can make my line, and I'll leave that in red. No, I didn't put arrows on this. And there should be arrows at the end of it. So there is that first one.
Special ed teachers, if you were testing today, could you make sure all computers are shut down so we can start to
The second one is
Thank
also
you.
in the equation of y equals mx plus b. So the first thing I'm going to plot is my minus 5. 1, 2, 3, 4, 5. And then this is a positive 6 over 1. So I'm going to go up 6. 1, 2, 3, 4, 5, 6 over 1. And so then when I do this, I'll do this. Arrow both, yay. And blue, it looks something like that. So that's where those lines cross. And if I look, my point of intersection is right there. And that coordinate point, my x value is 1, and my y value is 1. So that would be my solution. Or I can even say x equals 1, y equals 1, same thing. So over here, I'm going to do the same thing now. The first one should be, so already that first one I think was, yeah, red. So this one is going to be red. So this is already in the form of y equals mx plus b, so I go to negative 4. 1, 2, 3, 4. X is the same thing as 1x, which is 1 over 1, so I'm just going up 1, over 1, up 1, over 1. And that's all I'm doing the whole time. So I'm just going to make that line. Like something like that. Then for this one, I'm going to put this in the form of y equals mx plus b. So if I have this, 3x plus 3y equals 6. If I want this to say y equals mx plus b, I want y by itself. So that means I need to get rid of this 3x. So this cancels, and now I have 3y equals negative 3x plus 6. And I want y by itself, so I divide by 3, which means I divide this by 3 and I divide this by 3. So then I get y equals negative 3 divided by 3 is a negative 1, which is the same thing as just negative x. 6 divided by 3 is 2. So then I can go positive 2, 1, 2, and then the slope is negative x, which is a negative 1 over 1. So down 1, back 1, down 1, back 1, and I draw this line. And they intersect. If you're looking, they intersect right here. Oh, that's still in blue. Let me make that black. They intersect right here, and that coordinate point, my x is 1, 2, 3, and my y is negative 1. Again, you could have done this equation by just plotting 2 points. So I could have plugged a 0 in for x, so it would have been 0 plus 3y equals 6. Divide by 3, divide by 3, y equals 2. So then I could have done this, y is 2. Up there's that point right there. And then I could have done it again where I make my y equals 0. So 3 times 0 is 0. Divide by 3, divide by 3. So then my x equals 2, 1, 2. And I would have just plotted those 2 points instead of changing it in the equation. You can pick whichever way you want. Up to you. All right, so we have some special cases. So I'm going to first do them, and I'm going to talk about how you could have solved it otherwise. So here, we have minus 2, 1, 2. I'm going to go up 1, 2, 3 over 1, up 1, 2, 3 over 1. So there's my line. Oop, line I want red. And now I'm going to go to blue. It's already in the form, so it's starting at +1. I'm going up 1, 2, 3 over 1, 1, 2, 3 over 1. And that line's not really that straight, it should be there. Now, you might not be able to see it, but these two lines are actually parallel, so they're never going to touch. And one way that you could have noticed that before even doing it is they both have the same exact slope. So since they have the same slope, they're not going to intersect. So they're never going to touch each other. So for this one, we're going to say that there would be no solution. They never touch, so you can't ever find a point of intersection. There's no solution. Let's go back to red over here. This one's already in the form, so I go to +4, 1, 2, 3, 4. I go down 2 over 1, down 2 over 1, or you could have gone up 2, back 1, up 2, back 1, whatever you like. The graphing should not be the hard part. We already know how to do that. And then blue for this guy. Again, you could have solved for y, so now I'll do it the other way where I'm going to plug a 0 in for x. So then I divide by 2, y is going to give me 4. So y, 1, 2, 3, 4. And then I'm going to plug it in where now my y is 0, so now I have 4x plus 0 equals 8. I'm going to then divide by 4, x equals 2. So when I plot this, it's exactly the same line. They're the same exact line. So in this case, when they're exactly the same line, it's not just one point of intersection, everything is being intersected. Every single point on this line is being intersected, so there's infinite solutions. Because it's every single little point on the line, since both lines are the exact same. So it's infinite solutions. So before class, graph each set of lines in the graph provided and approximate the solution. So you're just doing what we did. You're graphing both of these, and then you're finding that point and telling me what that answer should be in a coordinate value, like what blank comma blank.